All right, welcome to 8.2, vectors in the coordinate plane. So, uh, this is kind of an extension with regards to 8.2, uh, rather 8.1 rather. We'll be able to calculate a little bit more vectors, and hopefully this section kind of clears up and paints a picture with regards to vectors. So first off, can we get those values of a vector? This right here, component form of vector, if I'm giving you 2 points, like we have a point A right here and a point B right here, initial and terminal point, if we take the values of x sub 2 minus x sub 1, meaning the x value of the terminal point minus the x value of the initial point, and then we do the same thing with the y values. Y value of the terminal minus the y value of the initial. That will get you a vector. Your vector that you're of AB. And it is written as AB with a little line with an arrow pointed to the right. Okay, so that's the definition of a component form of a vector. Take the terminal minus the initial, and you'll get your vector. So I have an example right here. So we have a point A as negative 2, negative 7, and point B as 6, 1, and we have the vector AB. So the letter that's to the right is your terminal, first letter initial. So terminal initial. So it's going to be a terminal minus initial. So 6 minus a negative 2 is 8. 1 minus a negative 7 is 8, giving you 8, 8. Next, we're going to calculate the magnitude. And magnitude is the distance traveled on that vector, okay? So if I'm giving you an initial and terminal point, the way to calculate your magnitude is x sub 1 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Add them up and find the square root as used by the formula. Now, if I give you the vector in a component form, this is called a component form right here, okay? A comma B. That's what you try to find in the last problem, is component form of vector. So if I'm going to do A comma B, just square both these, add them, and square root them. Okay, like so. We have an example right here. Let's solve it. So we have AB. We need to find the magnitude. So square root of negative 3 minus 8 squared plus negative 9 minus 0 squared. I'm going to get 121 plus 81 equals 200 and square 202. And the square root of 202 is equal to about 14.2. There you have it. All right, vector operation. So if we have vector A and vector B, adding two vectors together is add the first values together and the second values together. Subtracting, same thing. And scalar multiplication, when we see the word scalar, as you might remember from last section, is if it's just a number that's not part of your vector. Okay, so if you're taking a number and multiplying by a vector, just multiply each of the individual values by that value. Here's some examples of using those properties, right? So we have 4w plus z, and I gave you what w, y, and z are equal to, which you'll need for these. So if vector w is negative 4, 1, multiply that by 4 first before we add z to it. Then we're going to end up with an answer of negative 19, 4. Let's do the second one together. So once again, w and we're going to get minus z. So then I'm going to do all the multiplying first to make our life a little easier. And then add the first pair together, negative 8 plus 8 is 0. That works out nice. How about that? And then 2 plus 20 is 22. Be careful with our subtraction. So 0 minus negative 3 is 3. 22 minus 0 is 22. There's your answer. All right, so we're going to talk about unit vectors next. And a unit vector is a vector that has a magnitude of 1 unit. Okay? In order to find that, so this looks like a weird equation here, but it's really not. U is just our unit vector. V is the vector itself. And this, hopefully you remember from earlier in this video, is our magnitude of V. So really, all you're doing is you're taking the vector, finding its magnitude, and then dividing this whole vector by its magnitude. Let's do an example together. So once again, if I want to find the unit vector, let's find the magnitude. So negative 4 squared, 16. Negative 8 squared is 64. It's equal to square root of 80. I can simplify the square root of 80 a little bit more, and I'll get 4 root 5, because it's from root 16 and root 5. That's going to make our problem look a lot nicer. So when I do the vector, negative 4 divided by 4 root 5, comma, negative 8 over 4 root 5. Negative 4 divided by 4 is negative 1. How's that? How nice is that? U is equal to all this. So it's going to be negative 1 over root 5. And negative 8 divided by 4 is negative 2. So negative 2 over root 5. And to reiterate the definition from earlier, if you were to square the first term and the second term and add them up, the square root of that will be 1, which is how you find your magnitude, right? Because as you saw in the definition, is a unit vector is a vector that has a magnitude of unit 1. So if you were to find the magnitude of these values right here, it would be 1. Also, we should rationalize, multiply top and bottom by root 5, you get negative root 5 over 5, comma, negative 2 root 5 over 5. Another way to write our vectors is as a sum, and we usually just use where the first number is with an I, and then whatever the second number is with a J. I usually is the first number of our vector, J being the second one. We'll do an example next. All right, so we have DE, and it's a vector. We're going to write as a linear combination. So same story as before. We have point D and E. Now let's write as a vector. So same story. We're going to have negative 7. I need to get into pen mode. Negative 7, terminal minus initial. Terminal minus initial. So we have negative 7 minus a negative 3. That will get us a negative 4. So your I value is going to be negative 4i. And then we are going to have 1 minus a negative 8, which is going to get you a 9. 9j. Okay, so we did the same thing. We found the vector. We just use i's and j's instead of component form. Cool. All right. So if I give you the magnitude and the angle, you are able to find the vector as well. Because if you think about it, if we have a vector, you have your angle, right? Now this is not dealing with this because clearly this angle is not 210 degrees, but hypothetically, this is the angle we're trying to find, right? And we know what that value is, right? We know your magnitude, which is essentially what that value is. The first value is dealing with how far from left to right you went, and down to up you went for your second value right here, right? Which, as you know, up and down sign left to right cosine. If I know this value and I don't know what's down here, that's adjacent over hypotenuse. That's your sine value, right? So this is just like working with SOHCAHTOA right here, okay? I was solving for x, your first value, which is not what we're calling it, but cosine theta is equal to x over your magnitude. And then what do you get in order to find what this distance is right here? Multiply both sides by the magnitude, and look, that's what this is right here. Same story with the sine, okay? So if I give you magnitude and I give you the angle, all you need to do is plug them in, and then what comes out as a result? You'll get negative 12 root 3 for this one, and negative 12 for the other. That would be your vector in component form. Please read directions as to which form. It says component form. Linear combination will be I and J. All right, last problem. So we have find a direction of each angle to the nearest tenth of a degree. So if we drew this initial terminal right there, right? We'll call that. So we know this is negative 6, right? And you're down. Oh, I did that terribly wrong. Wow. Negative 6, and we're going up. Like that. Up 2. Cool. 2. 6. There we go. And you wanted to find the direction of each angle. You're doing, you have the opposite, you have the adjacent. You're doing tan. Tan theta is equal to what? Opposite over adjacent, right? 2 over 6. Now this is where it gets a little weird, okay? So if you did inverse tan like you should, and you should know, inverse tan of 2 over 6, what do you get? And you get theta is equal to 18.43, but that's not the answer, okay? Because what we need to find is what this is right here, okay? It's always going to be where it starts from to where it ends up, okay? So once again, we always start here, where we're ending up right there, okay? But we need to use tangent theta to get there. So we found this value right here to be 18.43. How are you going to find what this value is? Easy. It's 180 minus that. 180 minus that will get you 161.6 degrees. That's your answer. Appreciate you watching, and we'll see you in class. Bye-bye now.